Hello Year 5, welcome to Tuesday's math session where we are looking at can I compare and order fractions greater than 1? So yesterday you should have done comparing and ordering fractions less than 1 with Mrs. Elmore, and today we're going to hop over and do greater than 1. So pause me here, have a go at this starter today. Now remember back to our rounding knowledge, which place value column are you going to need to look at if you're rounding to the nearest 1000? And my top tip for this one would be to make sure you line up your numbers perfectly. Don't get confused with this cheeky 0. Okay, make sure you line them up perfectly. Okay, here are the answers. How many did you get right today? Well done for having a go at those on a Tuesday morning. Okay, right, can I compare and order fractions greater than 1? Right, let's start with using our fraction knowledge to solve these. What do you notice about these? Let's have a look at number 1. Now this is the equal sign, which means that these two fractions have to be equivalent. And if they're equivalent, what does that mean? It means we have to do the same to the bottom as the top. So what calculation did we do to get from 9 to 27? Yeah, we did 9 times 3. So that means our top number also has to times by 3. Okay, 2 times 3, nice and simple, is 6. So our number here is 6/27. Our fraction is 6/27. Okay, have a look at this one. Now we've got the missing symbol here. What symbol do we need to put in here? Have a think. Da, da, da. Yes, you've spotted it, hopefully. This is equivalent. Yes, we've done 7 times 2 gets to 14, and 9 times 2 gets to 18, which means this one is equivalent. So we put in our equal sign here. Right, let's pop on over to question 3. Now this one says this fraction is greater than 1. What does that mean for this fraction? What must it be if it's greater than 1? Now, if this fraction was equivalent to 1, it would be 7/7, 7/7, because that is the same as 1, but it's got to be greater than, which means it has to be an improper or top-heavy fraction, and that could have been 8/7, 9/7, it could have been 107/7, as long as it is greater than 7 and is a improper fraction. Okay, last one. Now this one's a little bit tricky, but how would you find the missing symbol here? Okay, what I would do is I would go, right, I can't really make my denominators the same, but I should be able to make my numerators the same. So if I times this one by 2, it should give me 2/16. And then I can look at it and I can compare it a little easier because I've got similar, or I've got the same numerator. They're identical numerators. My denominator is different, but my bigger denominator means it's the smaller fraction because there are more parts to it. So each part is smaller. So that must mean that this one is less than this one. So 2/19 is less than 1/8. So it's going to go like this. And here is your answer. I hope that reminded you of some of our fraction knowledge that we've been using. Let's carry on. Ooh, too fast. Okay, so today we're going to use bar models to help us compare, because bar models are brilliant. They're brilliant all the time, but especially so for fractions. So if you're ever stuck on a fractions question, draw out some bar models to help you out. I promise you it's going to help. So have a look at my bar models here. I'm going to change my pen colour, I think. Okay, use these bar models to compare 1 2/3 and 1 5/9. So my bar models here, I know that I'm going to need 2 of each because it's greater than 1, but it's less than 2. So I'm going to need 2 bar models per fraction. And the first one is going to be split into 3 because each one has 3 parts. Okay, then it says 1 whole. So I can colour in this whole thing, and you'll colour in much neater than me. with my digital pen. Okay, and then it says, right, I've got one whole and then I've got two parts, 2/3. So let's colour in 2/3 here. That's it. So now I've got my first fraction represented. Okay, let's go on to do 1 5/9. So my bar model has been split into 9 parts because there are 9 parts to each whole. Again, I've got a hole here. So I'm going to colour in my whole bar model. That's it. And then I've got how many parts? I've got 5 parts. So I'm going to colour in 1, 2, 3, 4, 5 parts. Now have a look at my bar models. What do you notice? Now at the start I made sure that my bar holes were the same size. So now it should be nice and easy to see which one is the greatest one. If I put my line down there, you can see that 1 2/3 is greater than 1 5/9. So my greater than one is going to go here. Get my pen back. So it's going to be 1 2/3 is greater than 1 5/9. That's it. And what I want you to do now is pause me and have a go at doing 1 5/8 and 1 1/2 compared just the way I did it with the bar models. Okay, I hope you've managed to compare those. Let me reveal the answer. There we go. 1 1/2 is smaller than 1 5/8. Okay, how are we going to compare these fractions? Well, here is a top fractions tip for you. When the denominators are the same, the greater the numerator, the greater the fraction. So the greater this one is, then the greater the fraction. So which one of these is bigger, do you reckon? Well, which one has the biggest numerator? 11/7. There are more sevenths here than there are here. So this one must be the greater one. Let me put in my symbol here. And I can show you this using a bar model. Here is my 11/7 and here are my 9/7. You can see I've split my holes into 7 parts and I've coloured in each of my parts to represent my numerators. So if the denominators are the same, then the greater the numerator, the greater the fraction. Okay, that's a really good top tip. I would even write that down on your book today to remind you for when you're working out some later. Okay, your turn. When the denominators are the same, the greater the numerator, the greater the fraction. That is your top tip. But these denominators are not the same. So what could we do? Pause me here. What could we do? Dun, dun, dun. Okay. Hopefully you've worked it out. We've managed to make these into the same denominator. We can do that by timesing this one because 5 times 2 makes 10. So we change this one, we go 5 times 2 equals 10. That's it. And that means 7 times 2, well that's 14. Now can you see it? Right. We've got the same denominator, they're both 10, which means the greater the numerator, the greater the fraction. So the greatest one here is 7/5, okay? You can see there's my bar model again. Now this is my bar model if they were in fifths. Actually, I've also done timesing it by 2 here to make them have the same denominator and therefore easier for us to compare. Okay, your turn. Pause me here. What are the symbols missing from these ones? Which ones are greater than the other? Have a look at how you are going to make sure that the denominators are the same. And remember, whatever you do to the bottom, you must also do to the top. Okay, pause me here. And then in 3, 2, 1, I'm going to show you the answers. Let's see. You can see my answers here. This one is going to be bigger because I've had to times this by 2, and 32 as our numerator is bigger than 29. So 32 parts is greater than 29 parts. Okay, I hope you got that right. Remember, if you're stuck or you're struggling, you can come along to the daily drop-in session today. Okay, Teddy has ordered the fractions from smallest to largest. What do you notice about each of these fractions? What do you notice? Well, first off, we've got some different denominators here. We've got 4, 4 and 8. So how can I make it so that all of my denominators are the same? Well, I can divide this one by 8. I can divide this one by 2 because 8 divided by 2 equals 4. So that's going to be 4. And then 30 divided by 2 is going to be 15. What a weird 2 that one was. Okay, now what do you notice? Now that we've done that equivalent, what do you notice? Ah, these two are the same. So these two are identical. What do you think about this one? Now, we did converting mixed numbers to improper fractions last week. Can you remember how to do it? So we do 3 times 4, 3 times 4, which is 12. And then we add on our parts. We've got 3 parts left. 12, add 3. And then our answer is going to be 15. And our denominator always stays the same. So it'll be 15 fours. So what has Teddy done? He has made a mistake. All of these are actually equal. They are all equivalent. Some dodgy equal signs going on here now. Okay. Ooh. There we go. Okay. Right then, next top tip. When the numerators are the same, the greater the denominator, the smaller the fraction. So this is the opposite way round, okay? When you have two numerators that are identical, then the greater the denominator, the smaller the fraction. And we can show you just like this. Okay, so this is 15/13 here, and I've put all of my holes into 13 parts, and I've coloured in 15 of them. And here I've split it into tens because that's my denominator, and I've coloured in 15 of them again because my parts are smaller. Even though I've got the same amount of parts, this one here, 15/13 is going to be smaller than 15/10. Okay, so we can add in our symbol here. This one is going to be the smallest one. Very good. Okay, can you see how that's represented using our bar model? So when the numerators are the same, the greater the denominator, the smaller the fraction. Okay, have a look at these fractions. How can we compare them? And remember, when the numerators are the same, the greater the denominator, the smaller the fraction. Have a think. Now, our denominators aren't really together. We can't really work with these. However, have a look at our numerators. Are they linked? Yes, we can times 9 by 3 to get to 27, which means we also have to times 5 by 3, which gives us 15. Okay, because remember, we always do the same to the top and the bottom. Okay, so now we've got two identical numerators. When the numerators are the same, the greater the denominator, the smaller the fraction. So the denominator here is greater, so this one is going to be our smallest fraction. There we go. Okay, have a look at this one. In fact, I'm just going to pause you here because I'm running out of time. Come and join me on this page for video number 2.